Alright, so as always, try the problem first, and then come back for the solution for the resistance equivalent, the current for all of it, the power, do your loop rules, do your junction rules, and then try to find the voltage and current. And you already will know it because I'll write it in a second, but also the resistance for each one. So the first resistor is 5 ohms, second resistor is 10 ohms, third is 2 ohms, and the fourth is 6 ohms. So first step, combine your R3 and R4 because they are nice and in series here, so it's nice and easy. And you will get 8. Your numbers will be a bit uglier on this. So it's 8 ohms. And then you have your parallels with the 10, so it would be 1 over 8. Plus 1 over 10. There are a couple, I'm going to do 1 over 40, or in this case, 5 over 40, because 5 times the top and the bottom. And then this is going to be times 4, so you get 4 on the top and the bottom. Good, 9 over 10. Flip it, 10 over 9. And you are going to get 1.1 ohm total. And I'm sorry, that's what I get for doing it without using a calculator. That's 9 over 40. That was not sitting right for me. That makes a lot more sense. So it's actually going to be 4.4, repeating on forever, stopped at the 0.4. That's not right. 4.4 ohms for this whole group right here. And then add it to your 5. So you're going to have, for your total equivalent resistance, 9.4. Alright, now we got our current, we got our total voltage. I is equal to V over R. So we only have a 9 volt over 9.4 ohms. And this is going to get you, you could round it, so it's going to be 0.95, or actually, excuse me, 96 with the rounding. I'm actually going to just make it 1 amp to make everyone's life easier. And round it up. Then, power is your volts times your current. So that's 9 volts times 1 amp. That will give you 9 watts of power. Alright. Now, loop rule. You should hopefully see that we have 1 loop here and a 2 loop there. So in the blue, we start with our 9 volt battery and subtract your first resistor, so volts 1, and subtract your second resistor, so volts 2, equals 0. Green, start with 9 volts, still going to hit that first one here. Go through, we're going to hit our third and fourth, and then come on home to 0 volts. Junction rule. We have a junction here and a junction here. So in orange, our current going in, our current going in is just coming from that first resistor, so I'm going to call that current 1, and that's equal to two new currents, so let's call them current 2 and current 3. Then when we get here, those two currents combine to go into that, and then come out as a brand new current, current 4, that will eventually go back home to our circuit. So you'll see I've made a little grid here at the bottom. So this is 1, 2, 3, and 4 positions. So remember, resistor 1, if you go back to the original picture, was 5 ohms. Resistor 2 was 10 ohms. Resistor 3 was 2 ohms. And resistor 4 was 6 ohms. Now we go to our voltage. We don't know any of our voltages yet, so we're going to leave that blank. However, we do know that our current for resistor 1, that's going to be their total current, and that's our total current. So you want to put that in for your total current. If you wrote this out a different way, but I find this is a really nice way to organize it. If I know the current, I can go over my scratch area and find the voltage. Voltage is equal to current times resistance. So that's 0.96 times 5 gives us, I believe, 4.8. Plug that in for our volts, 4.8 volts. We move on, and then we know from our previous loop rules that if this is 4.8, 9 minus 4.8 will give us 4.2. So I know my volt for my second is 4.2. Oh look, I know all of these things, so I can find my current, which is volts, which is my 4.2, over my 10 ohms, which will give me 0.42 amps. Alright, we continue. If this current, aka current 1, or actually current 2, excuse me, if current 2 is 0.42, and we know the total current, current 1, is 0.96, we can subtract and find our new current 3. So 0.96 minus 0.42 gives you 0.54. I'm doing this in my head, so check if my math is wrong. Now again, I don't know my voltage, so I can go back, plug in. 2 is my resistance, my current is 0.54. Multiply that, and that'll get us 1.08. So 1.08 volts here. Alright, so now we're onto our last one. So we can plug in again. This was 4.8. This was 1.08. Therefore, 9 minus 4.8 minus 1.08 is 3.12. So this is 3.12 volts. And we know our current has to be the same as the previous one, because they are on the same line. Hopefully this was informative and not too messy, and we will continue going over and practicing this tomorrow.